Hi and welcome to another episode of TRX Bench. Here today in the lab is a Yaesu FT-7800. So that radio came in with a receive problem on VHF. So VHF is, as I've been told, completely deaf. So let's see what's really going on with this radio. Let's try to fix it. Alright, and we are right into testing here, and radio is on 2 meter and it is connected to the generator, and yeah, so you hear that is a very noisy signal, but it should be an S9 signal, but here our S-meter indication is showing very low. And yeah, let's have a look on our communication tester. Yeah, we are not already reaching a synod of 12 with minus 93. Yeah, let's have a look. Yeah, here we have it. So yeah, approximately 6 up to 7 dB synod. And well, so, and frequency here looks not on frequency as well. You see that we have a very noisy audio, and that is what we clearly hear on our speaker as well. So yeah, let me simply increase here our signal. Now we are up to 20 dB, and you see how much I have to crank up here our signal, so that we are able to get a more or less good synod on one hand, and more or less stable audio, but still in the background. Don't know if you can hear it over the camera. There is still noise in the background, and so we are still not reaching S9 on the radio. So you see we only have 3 bars here, which is clearly telling yeah, that is not good. So let's test it on 70 centimeter. And here the situation is completely different, as you can see. So this is now minus 93 dBm, and you hear we have really a clean tone. So that is looking just fine. So let's have a look onto the tester, and we can see we have here a completely different situation. So with minus 93 dBm, so we are easily reaching 30 dB synod, and you see we have really a clean audio. So that is all as it should be. Okay, but let's check for sensitivity if really everything is fine here on 70 centimeter. So let's search our 12 dB point, and you see that the tester has already started the routine. And we are at minus 120 dBm for 12 dB synod, which should be approximately within the specs. So let me see, 0.5 for 12 dB synod, which is just fine. So on 70 centimeter everything is fine, no problem whatsoever. So let's dig into our 2-meter band. Yeah, and I mean, it is almost 30 dB missing on receive sensitivity. Okay, so let's first have a look into our block diagram to understand a little bit how the 2-meter pass is working. Okay, and here's what we need. So let's zoom in a little bit. Okay, so you see here we have our antenna input, and what we clearly see here, we have here UHF, RX and TX, and we have here our VHF, transmit and receive. So we do not need to follow our UHF path, so we are interested here in our VH path, of course. And as we follow along here, we already see that we have here our antenna switch, and you clearly can read it here, TX VHF, and there we have finally the split between transmit, because this here is the transmit line, and if our switch is turned to RX, then of course we have to follow here our bolt line, and we have to go up here. Let's see. Okay, so there is another band which is 200 to 300 megahertz, and is there another one as well somewhere? Let me double check. No, only this both, and of course for us important is here up to 200 megahertz, because our 2-meter ham radio band is exactly in this area from what is it, 108 megahertz up to 200. Don't know if you can read it, so let's zoom it in a little bit more, then it might be clear. Yeah, you can see it here, 108 up to 200, and that is exactly where we need to find our path. And this here, the Q1008, seems to be the first front-end transistor. So that all is very important, but we do not get enough information here. So we really need to dig a little bit deeper. I mean, we have here some front-end diodes which are important as well. And maybe, yeah, you can see it here. We have some diodes here in our antenna switch, and as well here diodes which all could be the problem up to our first front-end transistor. So as I said, let's go into the schematic, because we need to dig a little bit deeper. Yeah, and now it really helps if you have both side by side, the block diagram and the schematic, because the schematic for its own is a little bit confusing, because you have all the filtering here, and you really need to find your way through. And therefore we have seen here our antenna input, which is obviously here, this test point. And important to us is that now as we are trying to follow here our VHF path, we need to find all of these diodes to know the way through. And as we can see here, so D1073, D1072 must be on the way to the first front-end transistor. And if we go over here, so let me increase it a little bit as well, and you may see we follow here along, and we have here a lot of filtering, so we see it here all over. But important to us are this both diodes, 1073, 1072, which is this section here. And now we are searching for 1074, 1075, which are the diodes down here. Still not found our first transistor, so we follow along here on the block diagram, and we find here what is it, D1015 and D1016. And you see, if we are following along here, okay, so you see that we find here our D1016 and here the D1015, all right. And now if we follow along here and really go up here to the max, so let me see, so we are still looking here for the 1008, and here we have our 1008. So that means we need to check if the signal is really getting here to this transistor at least. So let me once again check here the path. So obviously it is here the D1015 over this coil, and if we follow along here, let's see, so it looks like that the path is going up to one of this gate here, gate 1 most likely, because gate 2 is setting here the gain of this dual gate transistor. Okay, and you see, yeah, we have here a voltage indication, and that is then obviously valid for the input level, which is described here at our antenna input. So anyways, that means let's radio crack open, and let's follow first of all the path from the antenna input to gate 1 of our first front-end transistor. So that is the plan, what we really should do first. Okay, and here we have the main board, and this is a double-sided board. So as far as I can see it, we have all the transmitter parts are most likely here on this side. So this is here the final stage, and here the output filtering, and here we have it looks like the audio amplifier, and here we have our main processor. This here seems to be a receive filter. Well, the only way now is to look here into the board plan to see where we find our diodes, our first front-end transistor. So yeah, so board plan, and then let's look out for the parts we need to check. Okay, and when I look here onto our part list, I can easily find our Q1008. Let's see that you can see it as well. So here is our 1008, okay, so our FET transistor, right? And if I go over here, what is it? It is the fourth part under this line here. We see 1, 2, 3, 4 that it is on side B of our PCB, and that is underneath. So we cannot get to the needed transistor by easily checking it here as it is. So it looks like that we really have to take out the board, and then we might be able to get to our part. But then we have the issue that we cannot cool the parts any longer, because the chassis is not any longer together with the board, where are all the parts, like the audio amplifier is on, and the audio amplifier needs to get cold, or yeah, so we need the heatsink, right? Okay, let's see where we have the diodes. So maybe we are lucky and find the diodes here on side A of our PCB. Yeah, but unfortunately that is the same if I'm looking for D1015 and 1016. We see that they both are on side B. So we are here. So well, you can't see it. One moment, I have to go up maybe. Yeah. So here you can see the D1015, D1016, and both are on side B of our PCB. So first what we need to do right now is to take the board out of the chassis to have access to the parts we need to check. Yeah, we have to desolder here the antenna connector, and we have to take old screws out, and most likely we need to take here the panel off to be able to lift it out. So old screws are out, and I've taken off here the front panel as well, as it is here connected through the front with this connector here. And now a part here from our fan, which we need to get off as well. Okay, so now, yeah, okay, so we have it out, and now we and then I have completely taken out here our antenna connector, because it would block here, you know, the PCB. So that is the easier way, and now it should be relatively easy, and you see it comes off quite easily. And yeah, so now you see this both heat sinks, which are here first of all the preamplifier, this little MOS-FET, and then of course here the final And you see we really have a lot of parts here on the B side of the PCB, and now I have to inspect it first, and then we decide how we proceed, because we really need to be very careful with the heat. But on the other hand, what I can see here on the chassis is a big dark burning mark, and I wonder if this is maybe here. Let me check where the burning mark is. So it is in this area here. And do we have something odd down there? Difficult to see. I believe I have to prepare here my microscope to see it a bit better. Okay, so we are ready for inspection. Okay, and we are here in the area where we have seen the burning mark on the chassis, and yeah, let's go here along. Let's see if I can get it a bit more sharp. Okay, so let's go along. If we can see here something. But no. So I really cannot see something special, so I do not see any burning marks here on the PCB, so everything is looking quite good, and I'm already much too far here down at the lower end of the PCB. So the burning mark is much higher, so it should be here in this area, but here is, as we can see, no, here is nothing. No helpful burning marks whatsoever. So I wonder where the burning mark on the chassis is coming from, because that is really a big one. So that is nothing like you know, a little dot or so. It is really dominant, so you really can see it on the chassis. But here on the PCB, as you can see, like me, there is definitely nothing. Okay, so that means we really have to go ahead and have to test it. So we need to measure it out. No other way we could go. Okay, so no burning marks. Let's go back here to our schematic. So once again, I believe that somewhat, you know, I mean, this diodes down here, this diodes here, or this diodes are always jeopardized if there is a strong signal at the input. and of course this one. So maybe we simply go down from here over this diodes to this diodes, and that is, as we already know in the signal path, which one was the one which is really responsible for our 2-meter path. So that is it is once again, it is the D1015. Okay, so let's simply start here with the D15, and then let's go down here 1074, 1075, and then over here to do you really see it? And then here over to 1073 and 1072. So that might be a good plan. Why? Well, I'm not so happy with really connecting the PCB to our power supply, as we really do not have a heatsink here anymore. I mean, I'm sure we can do it if we really have to, but if we are able to simply test the diodes with the diode test in our multimeter, then that might be fine. So first, before we really need to connect our board to power, and until we really have to connect a signal to the board and then follow with the spectrum analyzer, I really go the easy way. I try to find a broken diode, because that is my first guess. I try to find a broken diode simply with a multimeter. So therefore, as we said, let's first watch out for the D1015 and the D1016, and let's first of all test this both diodes. And we are here on the main unit, and it is a part layout side B. And now let's enlarge it to be able to find the diodes, and I have already watched in my part list, so we should be able to find the diodes here somewhere in this area. So let me enlarge it a little bit more, and let's see where we can find these suckers. Okay, so that looks good. Have a look. So we have our D15 and D16 right over there, and the first I just want to do, check it with the multimeter. And we can find the diodes right here. So these little tiny diodes here are our D1015 and D1016. And yeah, I've here my multimeter, and it is just switched to Diode Test, and that is what I'm going to do now. I'm simply checking it by Diode Testing. Alright, so let's go back here to this view that you can see what I'm doing, and let's start. So obviously this is here anode, and that is cathode. So I go here with plus to the anode, and with minus to the cathode. Let's see what we have here. and that is a beep. A beep means we have a 0.7 volt drop, which is fine, and now we do it in the other direction, and there is no beep, so, and that is completely right, because it shouldn't be a voltage drop here on this side, and you do not hear a beep. Once again, the other way again, and you directly hear the beep, and that is 0.7 volt. Fine. So I believe this is good. I mean, remember, you never can be 100% sure if you test components in circuit, right? So the only thing I can do is to go through, and if I do not get a final result, then this test is not very helpful. So my hope is that I really can get here a clear indication that something is wrong. If I don't find it, we need to power the board up, so no other way. Okay, so let's go further, and let me double check. So that was a D16, and the right one is a D15. So this is a D15, so let's go to the anode with plus, and let's go to minus here, and that is good as well. So both are obviously fine, obviously, so no problem. Let me double check here. Yeah, so that is fine, and now we have to go farther, and we do the same with all the diodes we have here in the pass. Okay, so we really need to connect a signal here to our board. There is no other way. So I have already here connected here our antenna connector, and as well I built here a little stand that it is easier to work here on the board. Otherwise, you know, it is flipping around a little bit, and therefore this is really a nice way to handle it. And now of course we have to connect our front panel, and then we should be able to switch the radio on and to test for our lost signal. And well, we really have to check here the voltage regulators and the audio amplifier, because both is definitely jeopardized, so we do not need tone. So therefore I close the audio volume control completely counterclockwise to get the minimum needed heat to our parts, but our voltage regulator, so that will be used for sure. So yeah, we need to be a little bit careful, and therefore again, let's start here with our both diodes, which we already found, and let's see if we can see our signal up there. Okay, so everything is prepared. Yeah, so the generator is connected as well, power supply, everything fine. So let's check what we have. Hello? I mean, what the heck is this? Have a look. So we have full signal. Let me check here our temperature. That is already warm. Let me, I do not understand what's really going on. So have a look. Okay, so radio is off for the moment in time because I have just repositioned the camera first, because when I touch the audio IC, it is already really warm. So anyway, so let's see if we have now the same I've seen a couple of seconds ago. So I'm switching back the radio in, and we are on 2 meter, and I put in here some audio signal, and hey, have a look. So it is back. Have a look. 33 dB synod. So let me see what's going on. 12 dB. So let's go for a sensitivity test, and it is minus 108, which is still not enough. So that is funny. It is not completely sensitive for the moment in time, but come on, that is somewhat funny. Don't believe it. Okay, and I'm back here at D15. So, you know, the only thing I've done, I've touched, of course, here the solder joints for testing, but you know, that is exactly the part of the chassis where we have the burning mark, and I really wonder if the D15, which is the right one here, has a crack here. So you see that there is maybe something going on here on this diode. So that is really funny. I mean, I have done nothing different than only touching here the diodes, and after I've done so, we have not a perfect receive, but it is almost good, and therefore I really wonder, is you see how the light is here falling on the diodes, so it might be a crack. So that is really funny. Okay, I somewhat still believe that we have a problem here with our diode. Maybe it is an intermittent connection, or maybe at least a bad solder joint. Anyways, I have here a pin diode which is not the same package as you see, but electrically it is even better than the one we have here in. So what I just want to know, if I swap out the diodes, and this should not be the biggest problem to get it in, as yeah, it is definitely possible. So I just want to try it, and let's see if electrically then we have a better receive value, and if so, then we can be sure that something is wrong here with this little sucker. So you know, it is somewhat funny. So if you just hit it a little bit, then you see that the synod is jumping, and so forth and so forth. So to be honest, I do not trust this little diode, and I just want to get it out and see what will happening with the new one. Okay, so we take the D15 out. First, as always, a little bit flux, and then let's see if we can get it managed. Let's see what we can do so far. Okay. Let me double check if you can see it. Everything here. And okay. Yeah, here we have it. Excellent. So our old diode is out, and we can go for our new diode. Let me prepare it a little bit. Just let me clean up the joints, and then we have a better starting point. Okay, not much done so far. I've only cleaned the PET and the new diode, and here on the board it really looks like a monster diode, so it's right in place. So let's see if we can get it handled so that we get really this monster here in our position. Let's see. Okay. So, and always watch the orientation. So where is my SMD solder? Here it is. So let's see. Because of course we need to do the second end. Where are we here on the board? Can't find it. Unbelievable. Here we are. Okay. So let's see. Yeah, very nice. So, and then let's simply refresh here this as well. Okay, and of course we do the other side as well. Cannot get to it very good. Alright, so that is looking just fine. And really now I'm curious if this is working somewhat better. Okay, so sucker off, and let's go ahead. Okay, so let's clean a little bit here our situation on the board, and then I will put it back into the chassis to have the best cooling conditions to be able to perform a complete test, because you know otherwise it is always a little bit difficult, because I really do not want to destroy here our ICs on the board. So let me put it back into the chassis right now. Alright, so our radio is back in the unit, and it really looks great. So we hear a noisy signal but we clearly hear the tone. So let me switch it off because it is really annoying, and let me simply here go over to the tester, and that is really amazing. So you see we are on 145 to 90, and you see that with minus 121 dBm, okay, so here we have the figure, we are able to peaking 16-17 dB Synod, and that is awesome because the spec is telling us that with minus 121, which is 0.2 microvolt, we should be able to peak 12 dB, and we are even, I don't know, 6 dB, 5 dB better than what the specs are telling us. And we hear and we can see that it is still, even in the noise, it is still a signal which can be heard by your radio partner on distant end. But let's look into the specs that you see what I have told you. Okay, and here are the specs, and let me zoom in a little bit more, and now let's go down to sensitivity, and here we have the sensitivity figures, and of course we are where are we here, 137 up to 150 megahertz, right, with 0.2 microvolt we should be able to peak 12 dB Synod, and again we are even much better. Okay, so as we have seen, 5 or even 6 dB, and yeah, that is what I've told you. Maybe this diode helps a little bit. It has a better on resistor, so this pin diode, so even that might be the reason why it is better. Once again 0.2, okay, and of course we can simply switch it to microvolt, and now you see it is 0.199 microvolt. Specs are telling us 0.2, so you see our radio is even better in specs, so that is awesome. And down there once again, so there is our yeah, little diode. So for comparison, here a 10-cent coin, and yeah, if you go down, I losing focus. But what I wanted to tell you is I have tested it once again with the meter, with the diode test in the multimeter, and yeah, it is really funny. I have never had a pin diode which is intermittent open, but that is what I have seen here. So you test it and it is just fine, and you test it again a couple of seconds later, and then suddenly it is completely open. So definitely I'm still not sure if what we have seen was a crack, but anyways, I mean, we have touched it and suddenly you have seen it. We had a good reception. I mean, not we didn't had the full sensitivity which we have now, so something was wrong. And so yeah, that is really funny, having a pin diode which is intermittent open. Anyways, we found this sucker, and radio is working just fine. Okay, and finally let's check if our transmitter is working. So just set it on high power and let's see what we get out of it. And 43 watt, so that is fine. 1 2 1 2 1 2 1 2, and we see that we have deviation, so that is working fine. So final stage is fine, deviation is there, and still an excellent synod with only minus 120 dBm. So that means we are really at the end of our video. Thanks for watching, hope you enjoyed it, and catch you next time. Bye!